If you're searching for the latest airborne technology in Alameda, California, you'll need to look to the skies.
If you're close, it almost looks like a stunt kite flying lazy circles in the sky.
But out for a weekend stroll, it is not. Even in winds as low as 12 miles an hour, about the speed of an easy bike ride, it can circle at speeds nearing 80 miles an hour. This power-generating machine is called the airborne wind turbine, and it's not too hard to imagine where the inspiration came from.
And as there is a group of us who are inspired primarily from kite surfing, being able to have this very small, lightweight wing literally yank us up off the water.
The basic idea has been around since the 1970s, but it was the materials and structural design that were elusive until now. The basic science of how the airborne turbine gathers energy is still quite traditional. Conventional turbine blades extract energy from wind by creating lift. This machine works in much the same way, but it flies in a circular path, the same path as the very tips of traditional turbine wings. The benefit is obvious: more energy efficient and made with 90% less material.
We're just getting rid of all the mass that a wind turbine has that's not doing anything useful.
Yes, it looks simple, but it's the culmination of years of careful research and development.
In the beginning, we were trying all kinds of soft kites. We were attached to the back of the pickup truck. We were driving down the runway, when there was no wind. We were building kites that were 100 square meters and pulling boats. Where the team spent, countless days out in Kaupo and Maui testing, they 30-hour stints with no one sleeping.
7 prototypes later, they've reached new heights.
Our current prototype is a 30 kilowatt unit, and that powers about 10 homes. It's 8 meters across, and it weighs about 55 kilograms.
And propelling their next phase, support from Google and a $3 million grant from the US Department of Energy. And that has got the team thinking big.
Our first utility scale unit, that is a 600 kilowatt unit, so that powers about 300 homes. It is 27 meters across, so about a quarter of a football field.
A regular turbine has one generator in the center of the blades, but each of these wings has several generators, and they have 2 different jobs.
They fly us up into the air. Then when we're up in the wind, we start using this generator to pull power out of the wind. So these propellers become our turbine blades.
And to ensure the wing can take off and land on its own, they're using processing power a bit like the one in your cell phone.
Inside here, there's the flight computer. There's a bunch of different sensors, a rudder, and then an all-moving elevator surface. And so these control surfaces are what we use to fly whatever path we decide is best for generating power.
Once on that path, the energy load is supported by cable tethers instead of the traditional tower. This makes deep offshore kite turbine farms a real possibility. That's where the winds are strongest, and tethers could reach 300 meters high as the Eiffel Tower.
In 20 years, I think you'll see farms in the ocean. You will see the Hawaiian Islands being powered by kites.
Lofty goals for a company rising to the challenges of the world's fastest growing energy